I presented this as a poster two Toward the Science of Consciousness conferences out in Tucson, and at an high-level artificial intelligence conference in New York, and nobody seems to understand it. And I think that's perhaps in part because the basic concept is so simple. And sometimes the simplest things are the hardest things to make a paradigm shift on. Anyway, it will help me communicate with you to kind of have some feeling of what your concept of consciousness is. We can talk about that for 6 minutes till it's time to officially start. So, if you were to describe your consciousness as a phenomenon to people, trying to be a little bit scientific about it, trying to sort of describe it, what would be some of your descriptions? Anybody? Any?
I think awareness.
Right, exactly. So that's my key. But how would you, this whole theory largely depends on the idea of explaining qualities of consciousness. I think almost anybody would admit, oh yes, a simple mechanical key like a latch on a doorknob has awareness of whether the door is locked or not. But they say, but that's nothing like my consciousness. And I would agree with them. I'm going to show at one point a little video clip of animations of the brilliant evolutionary biotech which is created by the intelligent design of evolution. Remember there was something about intelligent design? Mm-hmm. Well, somebody came out with a book called Darwin's Brain and basically said evolution is a form of intelligent design. It's trial by error, but it's trial by error weighted by breeding the most successful current candidates for solving a problem, giving them preferential breeding, but mixing their qualities, and then letting those guys compete. And this film will show you just some of that brilliance, and I'm saying I will show you that brilliance to basically let you say, this architect, this absolutely brilliant, intelligent design of biological evolution has also created what is probably the world's, the human brain is probably more powerful by certain important metrics that are important for creating the type of conscious awareness that your brain has, than any single supercomputer on Earth today, between your ears. And it's understanding that power allows you to understand that your brain can compute an awareness of information, which is astounding, and capable of having all the qualities that you can perceive in your own consciousness. This is the computational awareness theory of consciousness, which hypothesizes that conscious awareness is nothing but the awareness of information inherent in certain brain computation. Excuse me. Your brain is actually capable of doing a fair amount of computation when you're not conscious, and sleep is considered, dreams are considered conscious. What it is its complexity is greatly reduced, and its communication and unification is greatly reduced, so that there's not as broad a unified awareness. But the fact that I'm saying it's nothing but computational awareness is not in any way diminishing the magic of consciousness. I think consciousness is a great miracle. Religiously, I consider myself a realityist. I think the reality as described by science has many of the attributes of God. It has incredible power. It's gone on forever. It controls our fate. It has created us, and it will kill us. And it is worth worshiping before, if worshiping means trying to understand it so you can have the best life possible in it. And it's my belief in the magic of consciousness and just the magic of the world, the magic of beautiful plants, the flowers in the springtime, that makes me think that this is something worth worshiping. So I'm not diminishing consciousness. In fact, I think the more you understand it, the more you understand it's magical, in the sense of magic meaning something that is marvelous.
Can you give us your definition of consciousness?
Well, my definition of consciousness is awareness of information with having certain qualities, and I will discuss the qualities. I'll discuss them briefly in just a second. Let me just read this a little bit, and then we can ask questions. So, because the brain's computation, the reason why I'm not diminishing it is because the brain's computation has such an amazing awareness of information, one that appears capable of having all the qualities of awareness we experience in human consciousness. The brain has awareness of information that is massively parallel, massively differentiated, full of meaning and feeling, highly dynamic, variably focused, and most importantly, even though this repeats on the other, it's unification. All reality has awareness, but most of it is not unified in the way that the awareness in our brain is. And also, I should put it, it's representational. A lot of reality's computation is actually just sort of doing what it's doing, molecules bouncing off each other, or things falling and creating a vibration and a thud and a sound wave and that sort of stuff. But in the brain, this computation is of representational information. It's representing images and sounds and things that are coming in, like, according to an analogy to Plato's cave, you know, reality was what projected shadows on the cave that was the wall of your mind. And the cortex is the wall of your mind upon which the brain actually sort of projects these activations that reflect representational images of the space around you, of sounds, of people, of things. And anyway, so for one example of how special the brain's computation is, the bandwidth of the brain's computational awareness is greater than that of 100 million simultaneous DVD channels. The brain, the human brain has roughly 200 trillion synapses, each of which can represent an on and off. When it fires, they operate at about a millisecond. You do the numbers, and you're getting into huge numbers of the awareness of your brain. So you have to understand the complexity out of which this wonderful consciousness can be woven. And that's enough awareness of information to explain all the richness of human conscious awareness. The widely believed hard problem of consciousness and many other dualist theories claim science provides no basis for explaining conscious awareness. This is false. Consciousness is nothing but a very special awareness of information, and science demands all reality have awareness of information. We call this awareness inherent in all computation, computational awareness, or comp-awareness for short. For example, Isaac Newton's famous formula, force equals mass times acceleration, can only work if the reality computing it has comp-awareness of the current force and mass relevant to the object whose acceleration is being computed. Do people sort of understand that basic idea that reality doesn't compute without awareness of information? So that is a major blow to the traditional dualist concept that consciousness is so different than anything in reality. Reality's comp-awareness is not just of a few variables in an elementary physics equation. It's awareness of the massively parallel values that define all reality. An awareness of a sea of values astronomically large, Planck length fine, varying trillions of times a second. A Planck length is something like roughly 10 to the minus 34th meter. It makes the proton look huge. It makes the protons almost seem like a not a galaxy, but my brain, I'm drawing a blank. You get old, this happens.
A universe?
No,
Solar system.
Solar system, that's right. Yeah.
That's usually the analogy.
Yes. The computational awareness of the universe is arguably a great spirit, And I don't go into it here because I'm saying, but the qualities of comp-awareness vary with the qualities of computation of which they're part. I don't want to diminish the idea that reality might be a spirit that has some of the qualities of the human brain larger than us, because there are things like perhaps quantum entanglements and other types of connections which actually might put some conscious-like qualities into it. But most of it doesn't have, at least most of our current descriptions of it doesn't have a lot of the conscious-like qualities. And when I say the qualities of comp-awareness vary with the qualities of computation of which they're part, that's of what's aware of what, when, how, and with what unities in such computation. More or less, if you just think in terms of science, what information does science tell you a given computation and reality have to have? And the computation and reality is anything that changes the state of the universe, like dropping a ball causes computation. The ball accelerates according to Newton's law. It's all being computed. So this whole world is this, it has to have awareness of all sorts of variables. All the equations of physics are computing in a massively parallel manner all through the universe. But most of that awareness does not have certain key qualities, like the types of unification of awareness that we have in the human brain. So only computation with brain-like qualities of awareness can have awareness with the qualities of awareness that we call consciousness. As stated above, brain computation has the qualities of being massively parallel. Of course, all reality is massively parallel, massively differentiated, massively unified, full of meaning derived from a lifetime of memories, perceptual memories. Meaning is another key aspect of consciousness. And meaning is actually being aware of many different things about something at once to various degrees, much of it in your subconscious. And that, my theory explains how you can generate that type of meaning. And science increasingly suggests brain computation as awareness of the same information at the same time as does conscious awareness. For example, by reading brain information, computers are increasingly capable of recognizing what images and words a human is consciously thinking of at the time. That's stunning, this very close correlation between what we know, are able to know scientifically about the brain and what the human is actually experiencing. This similarity between what consciousness and brain computation are aware of appears so detailed that Occam's razor strongly suggests they are the exact same thing. The comp-awareness theory hypothesizes that in fact these two awarenesses actually are the same thing. I.e., the consciousness is nothing but complex, unified brain comp-awareness. The burden of this theory is to explain how the informational awareness of brain computation can have all the rich, seemingly miraculous qualities we experience in consciousness. As I will try to explain in the following more technical portion of this presentation, the list of conscious qualities partially explained by this theory is already surprisingly long. As a brain science continues to learn with increasing rapidity more about the qualities of brain comp-awareness, the theory's ability to explain the qualities of consciousness will increase with similar rapidity. But first, let me hear what your major questions you have, if any, at this point. Any? Okay.
Is this theory only about humans?
No.
I'm thinking about amoebas. Do they have comp-awareness too? They
Well,
certainly
everything
are
all of reality has comp-awareness.
Okay.
The issue is, what are the qualities of that comp-awareness? And it's and basically, I'm going to show you in a second a video about biotechnology. Well, the biotechnology of, in this case, DNA and actually DNA replication. But and you see this, you realize just the complexity of a lot of reality. But I'm not saying that that has a consciousness that's anything like my consciousness as I stand here seeing people and knowing where I am and all that stuff, all much of it at the same time, not all. I mean, as a magician will tell you, people are aware of less than they think they're aware of much of the time. Yes?
Itzhak Bentov said in his book on consciousness that anything that can respond to a stimulus has some degree of consciousness.
So that would be exactly the same thing, because it depends how you define stimulus.
Well, he says like a hydrogen atom
Right,
can
okay,
respond
yes,
to
yes.
a
That's
magnetic force.
anything that can respond to
To
information.
anything.
Right. A stimulus I tend to think of as sort of a more biological thing. But,
Kicking the shins, but
Right,
this is
right.
smaller than that.
right, yes.
I'm not certain if what this is saying is that consciousness is an emergent property of matter itself, or if consciousnness is a
Yes.
separate thing from what matter is.
It's every bit as much part. It's every bit as much part of science as we understand it is mass and energy. It's every bit as basic to physics, even though nobody said so. It's a way of thinking about something differently. But it's every bit as fundamental because nothing computes without awareness of information.
But that includes the energy on both ends of it.
Well, energy is also equally a part, but I said of matter and energy, right?
You did. I was
Yeah.
saying the energy, even if it's not matter, everything has, at the bottom line of it, everything is made of energy.
Yes, that's E equals M squared, I would agree with that. So, yes.
So there may be different degrees of energy or different frequencies of vibrations or different combinations.
Yes, and basically, vibrations and frequencies are very important to the qualities of consciousness, but the frequencies involved in, say, like quantum mechanics are extremely high. And although the little components, it is very possible that I talk a lot about unification, and a lot of unification is achieved through synchrony, which is portions of the brain are vibrating in the same frequency, and that means that they're increasingly capable of hearing each other through the noise. The brain is very noisy. And it also means that other things will perceive them as united. So, it gets a multiple unity there, a unity of greater communication, intercommunication, and a greater unity of the rest of the brain perceiving them as unified through synchrony. And it's possible, the last tour of science of consciousness I went to, they were basically saying that one of the things that biochemistry has found recently is that certain biochemicals have mechanical vibrations that will stretch some of their bonds, and as their bonds get stretched, sometimes that will cause a quantum tuning to stop, and then when it comes back together, it will turn on again. And these are vibrating at molecular vibrational frequencies, and I don't know, in a large molecule, they're probably slower. In small molecules, you're talking about terahertz, trillions of times a second. So it is possible that if you hammer off, I don't believe in most hammer off stuff, but because he's acting like the actual.
Microtubule.
Yeah, well, he's talking I
wonder
forget
if
what
you
the dimers, which are these two similar molecules that come together in the basic chunks that make up a microtubule, that they basically have carbon rings in which the vibration, there's gaps in them, and it's electrostatically favorable if they'll both rotate their gaps at the same time, so to keep the electron as far away from each other as possible. That's lower energy. And basically, the idea is he thinks that could be some sort of quantum transmission, and that those type of vibrations they're lower energy if they're synced up together. And he thinks that there may be a large syncing between these quantum states. And so it is possible that there is a quantum aspect of the unification of the computation in your brain that is consumably maybe could actually communicate through space, you know what I mean? This is getting off the subject, but there's a very fascinating theory called backward in time physics. And basically, almost all the equations of physics can compute backwards. The major thing that doesn't compute backward is the tendency toward maximum randomness, and the fact that if a given small area of space, like an atom, all of a sudden radiates something, it tends to radiate circularly. And whereas, so that means that radiation goes out much better than it comes in, just because of the tendency toward maximum randomness. But he's saying he thinks there's a way that you can actually make this go backwards if you could overcome this. And he's basically saying perhaps one of the ways is that a quantum waveform tends to involve multiple sort of the equivalent of harmonic vibrations taking place at a different phase. So they're coming in and out of phase with each other. And that actually encodes a very high frequency, that forms a very high frequency coded signal. And if one of those things splits and those things remain in phase, they can preferentially communicate with each other because they have this synchronous lock that no other part of space does. And that actually could create a favorable communication channel through them in space, because the wave going back can be exactly in sync with the wave coming out. And so the waveforms reinforce each other. So, and so that, to the waveform going out and back, both that creates a preferential channel for communication. So anyway, there are all sorts of weird things that can be put on top of this theory, but they're not necessarily essential to it. Yes?
That what you just described there, we've been watching some materials on quantum mechanics recently in our 10 o'clock meeting with the church, and fascinated by the phenomenon of what appears to be instantaneous communication, for one better term, between particles that appear to be what you just described there. One is that, I can't remember the
Entanglement.
Pardon?
Non-locality.
Oh, right.
Yeah.
Well, the reason
This
that
appears to be impossible, but
right,
apparently
but the backward in time theory says no. If this backward in time theory happens, what happens is that basically, because, say for example, two things spin out like this, one of them could talk, this guy in the future could talk to this guy in the past, and that guy could then talk to this guy in the future over there, and it would appear to be going instantaneously, but not violating the speed of light.
Yeah.
So that's his theory. So, yes?
Yeah, I will grant that the brain is a computational device. There's ample evidence for that. However, the majority of the computations the brain engages in do not have access to consciousness or do not generate conscious processes. The computations involved in homeostasis, for example. So why is it, or how is it, that some of the processes in the brain seem to have some secret sauce or whatever that generate consciousness or allow access to consciousness, but the vast majority of computational processes generated by the brain do not result in consciousness or conscious awareness?
That's because of the difference. The brain does not all compute exactly the same. Different parts of the brain compute differently. And so not all parts of the brain, for example, get wide scale awareness of their vibrations.
What are the different types of computation then? And what type of computation would be linked with consciousness and what type wouldn't be? Because otherwise, if I just hear computation, I think of it in the standard sort of concatenation type
Right,
of
so
definition.
that relates to part of, how long is this allowed to go on?
I'll withdraw the question.
What?
I'll withdraw the question.
No, don't withdraw, because basically what you're asking relates to this question of what are the key aspects of consciousness and how, what sort of computational qualities support it, and not, for example, when you're asleep, your whole brain's unconscious. You basically go into D wave, not including dreaming. You disagree with that?
Don't consider that definition.
What?
No, I guess maybe, maybe
Actually,
you
with all
should have
due
ever been in your
respect,
class.
that's not correct.
That is not correct.
Well, it depends what you mean by consciousness.
That's it, the whole definition.
Right.
People assume that
there's no
consciousness is the
computational
prefrontal
awareness.
cortex whenever it's, no.
Well, Christoph Koch basically believes it's largely in the back part of the brain where you have the hypercenter of your brain is dedicated to representation. And it's the activation of representational patterns that are most closely associated with with qualities of conscious
The
awareness.
terminology that we've had into the 21st century, how do we get here? With conscious and unconscious, consciousness and unmanifest consciousness, that's what Deepak uses.
Yeah, and it's not just the back, I mean, the back of the brain is much more active during REM sleep and dreaming because most dreams tend to have visual content. Okay, but there's also intense activation in thalamic structures and frontal structures in various parts of the brain. In fact, there are parts of the brain that are more active when you dream than when you're awake, or when you're in stage 4.
You have dreamer's paralysis, but you're not asleep.
Right. What I was saying is, it is generally considered, most of the things they say non-REM sleep is unconscious. But that doesn't mean there isn't a lot of computational awareness.
If you're a
Yes.
Buddhist monk, for example, it's not unconscious. One of the goals of meditation and sleep yoga is in fact to carry awareness first from waking into REM and then into non-REM types of sleep.
There's
So
an argument about definitions here.
Right.
Yes.
Well, but if you are in fact doing that, then perhaps you're having a different type of sleep than a non-REM sleep. Whereas it's possible you could have a hybrid type of sleep that's not traditional REM sleep, but it's not traditional D-wave sleep either.
REM, you've got activation of all your neurotransmitters, like
Well, your
Use
brain
it for
has
memory
different
consolidation.
frequencies. When you're in what we call
You
normal
wouldn't
waking
be-
consciousness, it's doing
You
a lot
wouldn't
of
be talking about your
zigzag stuff. And
conscious
then if you slow it
Your
down,
conscious
you
guy.
get conscious on a different level. If you even slow it down even more, you get conscious in another way that you may not be aware of what all your brain's doing. But
You're never aware that all your brain's doing.
exactly, but I'm saying when people speak of awareness as being normal waking consciousness, there's a whole lot more of something
Yes.
going on than normal waking
No, yes,
consciousness.
yes,
Just
yes. I was
make it
class
fun.
of 69, 70 at college, so that was the age of sex, drugs, and rock and roll. My senior year at Harvard, I sought to do an independent study in artificial intelligence and took the fall term off from crew so I could do drugs.
Oh, you learned a lot, didn't you?
What? And
Often state to consciousness.
I made first boat in the spring, so I was very proud of that. But I didn't drink in the spring, didn't party in the spring. But it was very interesting to be studying artificial intelligence while doing early, experimentation with LSD, because you would read stuff and you say, oh, that's my brain doing that. You know
I
what I
was
mean?
about to ask you if you hung out with Timothy Leary.
No, he was ahead of me.
He was
He left
still
Harvard
married
in the
to.
early
Oh, he's
60s.
still active.
He was still married to Bob's wife, didn't he?
Could I toss one more question
Okay.
in, hoping it will be answered? At what point did consciousness begin in what we call the universe?
It depends. I mean, I'm a big believer that my cat has a consciousness that shares certain qualities with my consciousness, you know what I mean?
Most of us agree with that.
Right, so I don't know. And because computational awareness, consciousness is a very special computational awareness. All of reality has computational awareness, and the line between what is conscious and what is not is a hard one to define. It depends what qualities you consider to be essential to consciousness. Does a snail have consciousness?
Does an atom have consciousness?
Well, it has computational awareness, but I would say that a fly has a more meaningful consciousness than an atom. You know what I mean?
And the more stuff you have interacting, the more complex your consciousness gets.
Right. The more you have a complex state of awareness, particularly, I mean, the fly has representational awareness. They see things. They hear the sound, you know, when they feel the air when you move your hand to swat them. They, you know, if you pick off their leg, they're unhappy about it, they're hurt, you know, I think they have something equivalent to pain.
How do you know that?
Just because motivation is very valuable for any sort of brain. The first time I took acid was spring my junior year, and it was after I just won the Eastern Spruance as JV, and so there was a party, and I could drink for the next week before we had to prepare for the Yale race. And so I hooked up with this friend of mine a roommate, who was, for the last 2 years, the female lead in the Hasty Pudding Show. If you know what the Hasty Pudding Show is, it's a show they used to put on where the female roles are all played by men. And so he was and anyway, he hooked me up with this black fellow whose father was a bus driver in Watts, and we took it, and then I didn't remember anything until 6 o'clock in the morning. We were hanging out by this ugly statue of 2 rhinoceroses by the chemistry buildings right near the museum that we went to. And I remember I said, that's where the rhinoceroses are, but they put an extra building there now. And I had this flash, which was, I was trying to say, what is the role of reason, what is the role of emotion in your life, what should be a proper balancing? And I had this flash, which I think is a very valid thought, which is if your mind was totally open to considering things, the combinatorial explosion of the space of things you can consider is so large that it would be astronomically improbable that you would ever think of anything that had anything to do with maintaining your own existence. So that means for a brain to be self-sustaining, there have to be emotions, or something like values. There have to be values that govern them. So even very primitive animals have sort of attraction and avoidance mechanisms, and don't do that against mechanisms. And one of the things when I try to explain feelings, emotions evolve from these primitive signals to very, very primitive brains. Don't do it, or do it. And these are the brains that can't even really think much at all. So it doesn't give you a lecture about don't do it, why. It just says don't do it in a way that makes you not to want to do it.
Is the computational awareness the same as consciousness? Is that?
Consciousness is a very special form of computational awareness.
Okay. Okay.
So all reality has computational awareness. It takes a very powerful supercomputer to create a consciousness like you and I have.
And is that
A less powerful one will compute the consciousness your cat has if you have a cat or a dog.
right? Is that because we have like feelings and emotions and stuff, or is that a whole other can of worms? Or something?
Well, I was saying I think even very primitive animals have feelings.
Yeah.
I mean, you know, flies can act like they're unhappy about something. I mean, very lower animals can have attraction avoidance mechanisms. So anyway, here's a little video, and this is, as I said,
and I wondered whether we could use computer graphics to represent the molecular world. What would it look like? And that's how I really began. So let's begin. This is DNA in its classic double helix form, and it's from X-ray crystallography, so it's an accurate model of DNA. If we unwind the double helix and unzip the 2 strands, you see these things that look like teeth. Those are the letters of genetic code, the 25,000 genes you've got written in your DNA. This is what they typically talk about, the genetic code. This is what they're talking about. But I want to talk about a different aspect of DNA science, and that is the physical nature of DNA. And it's these 2 strands that run in opposite directions for reasons I can't go into right now, but they physically run in opposite directions, which creates a number of complications for your living cells, as you're about to see, most particularly when DNA is being copied. And so what I'm about to show you is an accurate representation of the actual DNA replication machine that's occurring right now inside your body, at least 2002 biology. So DNA is entering the production line from the left-hand side, and it hits this collection, this miniature biochemical machines that are pulling apart the DNA strand and making an exact copy. So DNA comes in, it hits this blue donut-shaped structure, and it's ripped apart into its two strands. One strand can be copied directly, and it can be seen spooling off down to the bottom there. But things aren't so simple for the other strand because it must be copied backwards. So it's thrown out repeatedly in these loops and copied one section at a time, creating two new DNA molecules. Now, you have billions of this machine right now whirring away inside you, copying your DNA with exquisite fidelity. It's an accurate representation, and it's pretty much at the correct speed for what is occurring inside you. But I've left out error correction and a bunch of other things. This was work from a number of years ago. Thank you. This is work from a number of years ago, but what I want to show you next is updated science. It's updated technology. So again, we begin with DNA, and it's jiggling and wiggling there because of the surrounding soup of molecules, which I've stripped away so you can see something. DNA is about 2 nanometers across, which is really quite tiny. But in each one of your cells, each strand of DNA is about 30 to 40 million nanometers long. So to keep the DNA organized, to regulate access to the genetic code, it's wrapped around these purple proteins. I've labeled them purple here. It's packaged up and bundled up. All of its field of view is a single strand of DNA. This huge package of DNA is called a chromosome, and we'll come back to chromosomes in a minute. We're pulling out, we're zooming out through a nuclear pore, which is sort of the gateway to this compartment that holds all the DNA called the nucleus. All of this field of view is about a semester's worth of biology, and I've got 7 minutes, so we're not going to be able to do that today. No, I'm being told no. This is the way a living cell looks down a light microscope, and it's been filmed under time-lapse, which is why you can see it moving. The nuclear envelope breaks down. These sausage-shaped things are the chromosomes, and we'll focus on them. They go through this very striking motion that is focused on these little red spots. When the cell feels it's ready to go, it rips apart the chromosome. One set of DNA goes to one side, the other side gets the other set of DNA, identical copies of DNA, and then the cell splits down the middle. And again, you have billions of cells undergoing this process right now inside of you. Now we're going to rewind and just focus on the chromosomes and look at its structure and describe it. So again, here we are at that equator moment. The chromosomes line up, and if we isolate just one chromosome, we're going to pull it out and have a look at its structure. So this is one of the biggest molecular structures that you have, at least as far as we've discovered so far, inside of us. So this is a single chromosome, and you have 2 strands of DNA in each chromosome. One is bundled up into one sausage, the other strand is bundled up into the other sausage. These things that look like whiskers that are sticking out from either side are the dynamic scaffolding of the cell. They're called microtubules, but name's not so important. But what we're going to focus on is this red region. I've labeled it red here, and it's the interface between the dynamic scaffolding and the chromosomes. It is obviously central to the movement of the chromosomes. We have no idea really as to how it's achieving that movement. We've been studying this thing called the kinetochore for over 100 years with intense study, and we're still just beginning to discover what it's all about. It is made up of about 200 different types of proteins, thousands of proteins in total. It is a signal broadcasting system. It broadcasts through chemical signals, telling the rest of the cell when it's ready, when it feels that everything is aligned and ready to go for the separation of the chromosomes. It is able to couple onto the growing and shrinking microtubules. It's transiently, it's involved with the growing of the microtubules, and it's able to transiently couple onto them. It's also a tension sensing system. It's able to feel when the cell is ready, when the chromosome is correctly positioned. It's turning green here because it feels that everything is just right. And you'll see that there's one little last bit that's still remaining red. And it's walked away down the microtubules. That is the signal broadcasting system sending out the stop signal, and it's walked away. I mean, it's that mechanical. It's molecular clockwork. This is how you work at the molecular scale. So with a little bit of molecular eye candy, we've got kinesins, which are the orange ones. They're little molecular courier molecules walking one way. And here are the dynein. They're carrying that broadcasting system, and they've got their long legs so they can step around obstacles and so on. So again, this is all derived accurately from the science. The problem is we can't show it to you any other way. Exploring at the frontier of science, at the frontier of human understanding, is mind-blowing. Discovering this stuff is certainly a pleasurable incentive to work in science. But most medical researchers this is just discovering this stuff is simply steps along the path to the big goals, which are to eradicate disease, to eliminate the suffering and the misery that disease causes, and to lift people out of poverty. Thank you.
So I think, you know, one of the things, if I could get funding, is I'd like to basically do an animation of how your brain computes your soul, because it's pretty complicated to explain. Word document.
Just
Yes?
for Dr. Brooks' benefit here, the DNA and what that whole replication process right there follows the law of octaves of AIDS. You know what the law of octaves is? DNA, Dr. David Deemer has done it on how it's musically encoded. It follows the law of octaves.
Okay.
So it's a communication system, but it's the music, the harmony of the universe.
Right, so that, yes, and there's a guy called Arianen Bandyopadhyay, who basically went from like some of the highest signals that we can currently measure down to geological time, finding that across much of this space there's certain sort of like repetitions for sort of what would be the equivalent of each octave. An octave is a doubling in frequency, and I don't know if it was doubling in frequencies. He was going, these patterns would occur across, you know, I don't know what, maybe 1,000-fold or 100-fold. So it was more like universal harmonies, if you know what I mean. But yes, that's very possible, and basically they think that in the brain a lot of those type of frequency bands exist in the vibration of the molecules. So anyway, I presented that. You have to understand, this is the brilliant, intelligent design of evolutionary biotechnology, which is what biology is. And the same engineering brain, trial and error of evolution, has basically crafted a supercomputer in your brain that probably stores several petabytes of information. It doesn't do it, it does it statistically. It's not sharp memory like our current computers. It's a statistical computer. But it's probably stores at least several petabytes of information. As I said, just the cortex alone may well have a computational bandwidth equivalent to 100 million DVD channels. So looking at that, I don't know about you, my feeling is, damn, how clever that is. I mean, imagine if there was some biotech guy who came up with this when nobody had ever seen it before. They'd say, that's crazy. And yet that's how your body works. And so I'm saying that same just craziness is in your brain. The brain is this amazing device.